What if the key to understanding Earth's ancient climate was hidden in the chompers of long-extinct giants? A groundbreaking study reveals that dinosaur teeth, those ancient bite-sized time capsules, hold secrets about a world where carbon dioxide levels were sky-high, far beyond anything we see today. But here's where it gets controversial. Could these prehistoric CO₂ spikes have been a double-edged sword, fueling lush ecosystems while also hinting at climate chaos? Let's dive into the jaw-dropping details. Picture this. 150 million years ago, the air was thick with carbon dioxide, a greenhouse gas that now dominates headlines about modern climate change. Researchers have cracked the code by analyzing something unexpected: dinosaur teeth. These hardy fossils, much like the enamel in your own mouth, act as tiny vaults for chemical clues. When dinosaurs inhaled, they absorbed oxygen from the atmosphere, which became locked into their tooth enamel. This enamel, tougher than bone, has survived the eons, offering a direct line to the past. The magic lies in oxygen isotopes, which are like chemical fingerprints. By studying the ratios of these isotopes, specifically oxygen-17, scientists can reconstruct ancient CO₂ levels. Why? Because plants and atmospheric CO₂ levels influence how these isotopes form. The results? During the Late Jurassic, CO₂ concentrations were a staggering 1,200 parts per million, ppm, quadruple pre-industrial levels, 280 ppm. The Late Cretaceous wasn't far behind, with 750 ppm. For context, today's CO₂ levels hover around 425 ppm, a number that's climbing fast. And this is the part most people miss. These CO₂ spikes weren't random. The study links them to volcanic eruptions, those fiery planet shapers. Take the Deccan Traps in India, a volcanic nightmare that spewed CO₂ at the end of the Cretaceous. The evidence? 2 dinosaur teeth, one from a Tyrannosaurus rex, the other from a Kaatedocus cyberi, showed isotopic patterns matching these eruptions. But wait, there's more. The research also uncovered a surprising twist. Plants during the Mesozoic were photosynthesizing at twice the rate of today. Higher CO₂ and warmer temperatures likely turbocharged plant growth, creating a greener, more vibrant world. This isn't just about ancient forests. It's a window into how ecosystems respond to climate shifts. Traditional methods for studying past climates rely on soil and marine sediments, but these can be tricky to interpret. Dinosaur teeth, however, offer a clearer, more direct signal. As study co-author Thomas Tutkin explains, this approach gives us a completely new view of Earth's past. Lead author Ding-Su Feng adds that understanding ancient atmospheric composition and plant productivity is crucial for unraveling long-term climate dynamics. So, what does this mean for us? The Mesozoic was a world of extremes: volcanoes, CO₂ surges, and thriving ecosystems. Could this ancient climate offer lessons for today's environmental challenges? Or is it a warning of what unchecked emissions might unleash? Share your thoughts in the comments. Do you think studying the past can truly guide our future? Or are we doomed to repeat history? More about chemistry, dinosaurs, evolving climate, new research, paleontology, teeth.